Hello?
Hello.
I really need automatic parking light for my car.
Oh, you should watch the video.
Hello everyone, we are from Group 32 from Electronic Circuit and Analog Electronic Laboratory final project. We're gonna present about our result. That is automatic vehicle parking light. But first thing first, we're gonna introduce ourselves. My name is Mufty Putratama Sumarto from Electrical Engineering. Next.
I'm Goldy Firman Pramana from Electrical Engineering.
I am Naufal Aulia Amanullah from Electrical Engineering.
My name is Robbiarsya Akmal from Electrical Engineering.
Okay, going to the first part, introduction will be presented by Goldy.
Okay, an automobile mobile or a car is the second most used vehicle after motorcycles in Indonesia. Cars have a lot of safety features nowadays that are becoming more sophisticated than previously. From airbag features, braking with the latest technology, enhanced car frames durability, car interior lights, and the one that will be discussed further is car's parking system. The parking system faces many problems in some parking environments. In order to solve this problem, a smart parking system must be developed. To overcome the problems of parking, various methods and resources have been initiated. As a result, many parking systems and innovation are being developed. In a vehicle, an automatic parking light is a very useful tool for assisting the driver in a low light situation. Indonesia, as an archipelago country, has limited street light and relies solely on reflector lamps, which is due to the distribution of electricity not yet widespread properly, especially for village streets which are not available either real or reflector lamps. This condition is exacerbated by the number of motorbike users who like to be inconsiderate and do not want to be blamed in case of an accident. Therefore, an additional device is required which is embedded in the vehicle. This device helps driver better see what is behind them when driving in reverse when vehicle gets too close to another vehicle directly behind it. This additional lighting is for parking support and uses the light as a variable for input signal. If there are any light that indicates a vehicle, the sensor will recognize it and the action of the bulb lamp will be turned on. In this final project, our main objective is to build the automatic parking light as one of the solutions from parking environment problems that could occur to car drivers. We will construct an electronic circuit that will be placed on the cars. The electronic circuit will consist of several components that have already been taught, electronic circuits, and dialog electronic laboratories.
Okay, maybe next we go to the circuit simulation and prototypes.
We designed this automatic vehicle parking lamp circuit by using prototype professional software. The component materials that needed to enable automatic vehicle parking lamp circuit is one battery 12 volt, one switch, two for N25 simulation purpose only, and two L1 for F1. For resistor, one diode, one N4001, one MOSFET BS170, one NPN silicon BGT BC547, one relay single pole single throw or SPST, two lamps, and three DC voltmeter and two DC ampermeter.
For the simulation, we need to work a method or a work step is required to assemble a vehicle parking light circuit. So there are a few steps to make the circuit. The first is we open the Fortius software, and then, okay, next we select the component mode. Then we select the P sign and find all the components which already said before, which is first is the battery, then the switch, then the photo transistor, which is the 4N25, the resistor, the diode, which is the 1N4001, the MOSFET, which is the BS170, the BJT, the BC547, the relay, and the lamp. Then we put all the components and connect all of them. After all components are connected, select the instrument section and choose the DC voltmeter. And then we attach the first and second DC voltmeter to the positive side and the negative side of the light bulb. It is used to measure the clamp voltage on each light bulb. Then attach the third DC voltmeter to the relay input on the positive side and to the ground on the negative side. It is used to measure the voltage that enters the relay. Then on the instrument section, choose DC ampere meter. Then attach the first DC ampere meter between the switch and the first intersection R1. Then attach the second DC ampere meter between the intersection from the collector BJT BC547 and intersection from the diode D1.
For the working of the circuit, when the phototransistor is in high condition, which is it is exposed by the approaching vehicle light, the voltage flows from the collector through the emitter, and then the voltage will flow through the resistor, and it will flow to the BGT, which work as a switch and amplifier. After passing through the BGT, the voltage will enter the gate of MOSFET here, then exit through the drain MOSFET. Okay, this is the drain, this is the gate. Then it will flow to the relay and trigger the relay to connect with the lamp, which is in normally closed. Since the relay has an inductor to make the current don't move back and forth, we use a diode as a rectifier here. After the rectifier is connected, it will make this lamp turn on for 12 volt.
Okay, next we're going to simulate this circuit that we already arranged. There are several cases that we want to try. The first one is when the switch is in closed condition, but the both phototransistor in high condition. As you can see, if we simulate it, the LED will turn on. And then we move forward to the case 2. What if the switch is in closed condition, but left phototransistor in high, meanwhile the right one is in low condition? You can see the lamp is also turned on. And then next one, what if the left phototransistor in low and the right one is high? You can see it's also turned on. And the next one, the switch is in closed condition, but both of the phototransistor is in low condition. You can see the lights turn on or dim. And then next to the case number 5, what if we change the switch into an open condition, but both phototransistor are in high condition? It will also turn off, and then we're gonna change it the left phototransistor into high condition with the switch still open, and it is still turned off, and then we switch and add left phototransistor with low condition and the right one with high, still turn off, and the last one is both of the low condition and still turn off. Okay, from those cases, we can analyze that this this circuit lamp will turn on if the switch is closed, and then the phototransistor must turn on high situation, either or one or both of them. Okay, there is the analysis that we get from our main circuit. So this final project implements the electrical component that have been described or learned previously on the practical model. Because there's components, it's like diodes, MOSFET, BGT. The function of the diode can be used to protect against reverse polarity voltage, as well as rectifying voltage. And the MOSFET is used for switching. Meanwhile, the NPN transistor, the power will be flow from the collector to the emitter when power is applied to the base. The way it works is that a sensor in the form of a transistor will catch the light of another vehicle that is located behind, and the parking light will automatically turn on. Automatic lamp or bulb will turn on. Technically, the lamp will turn on if one or both of the phototransistors are on the high condition, and the circuit switch must be on. So there is our conclusion for this circuit and for this final project. Thank you for your attention. That's all for me.
Thank
Thank
you.
you.
Very much.